What we call the end behavior of a polynomial is determined by the degree of the polynomial and the leading coefficient. More so, it's determined by whether the degree is odd or even, and whether the leading coefficient is positive or negative. So we have four possible combinations here. In any case where the degree of the polynomial is odd, if it's odd, the two ends of the graph are going to go in opposite directions. If the degree of the polynomial is even, then the two ends go in the same direction. For instance, if you think about a line, the degree of a line is 1, and the ends of the line go in opposite directions. If the leading coefficient is positive, then as x approaches infinity, y also approaches positive infinity, and as x goes in the negative infinity direction, the y values also go in the negative direction. Now, this doesn't determine what goes on in between. The middle part is going to be controlled by the rest of the terms in the polynomial. But what goes on at the extremes is controlled strictly by the leading term. That's why they sometimes call it the dominating term. If the leading coefficient is a negative, then as x approaches positive infinity, the terms, the polynomial values, the y values approach negative infinity. As x approaches negative infinity, then the polynomial values, the y values, approach positive infinity. Again, this doesn't determine what goes on in the middle. So for instance, if you had a graph of f of x equals x cubed, if you think about your y values, as x goes 0, 1, 2, the y values go 0, 1, 8. So as x gets larger, the y values get even larger. So it's going to go off 1, 2, 3, 4, 5, 6, 7, 8. So we've got 0, 1, and 8. And then if we go in the negative direction, if we go with -1 and -2, those numbers cubed are -1 and -8. So here and here, so the graph looks something like this. So the end behavior, this is a positive coefficient, 1. So if we go back and look, it's fitting this pattern. Odd degree, positive exponent. If we look at f of x equals a negative x cubed, that basically just changes the signs on all of these. So the +2 would match up with the -8. The +1 would match up with the -1. 0 is still 0. and it's going to go like this. Of course, the negative is just going to cause a reflection about the x-axis from this graph. So we've got something like this, with the end behavior going in that direction and that direction for a negative coefficient, and that direction and that direction for a positive coefficient. On the other hand, if we have an even degree, like a parabola, then both ends are always going to go in the same direction. If the leading coefficient is positive, then it's going to go up as x approaches positive infinity and up as x approaches negative infinity. Does not tell us what's going on in between. If it has a negative coefficient, then it's going to go down as x approaches either positive or negative infinity. For instance, if we look at just f of x equals x squared, the graph's going to look like this. F of x equals a negative x squared. Again, the graph's going to be reflected about the x-axis, and it's going to go down. So here, as x approaches positive infinity, y approaches, they use the arrow for approaches, y approaches negative infinity. As x approaches negative infinity, y also approaches negative infinity. Here we would say as x approaches positive infinity, y approaches positive infinity, and as x approaches negative infinity, y approaches positive infinity. So an even exponent is always going to go in the same direction, and the direction is going to be whatever sign the leading coefficient has. If the exponent is odd, if the degree of the polynomial is odd, then as x approaches positive infinity, if the leading term is positive, then y is also going to go into positive infinity. They will go in opposite directions. So if x goes to negative infinity, y will go to negative infinity. If the leading term has a negative coefficient, then that changes. As x goes to positive infinity, the y values become negative. As x goes to negative infinity, the y values are positive. And this will give you a good start on graphing any kind of polynomial at all.